This video is about comparing different types of graphs. In physics, there are three main types of graphs: displacement versus time, velocity versus time, and acceleration versus time. The three different types of graphs are unique, and the graphs may look similar, but because we are looking at different y-axes, in this case displacement, velocities, or accelerations, they mean very distinctively different things. So you're going to need this paper out. Make sure you're turned to this page, and what we're going to do is we're going to look at what does the y-intercept, the slopes, what is a straight, curved, what does it mean we have areas under the curve, and we're going to look at all of these if we're going to fill this out. Now I will be using some calculus terms, but do not worry, those calculus terms will not matter. I'm using it for those who are in calculus, but those who are not, do not worry. You just ignore those terminologies. So if I use the word derivative or integral, ignore that. That's for the kids that are in the calculus class right now. So let's start off with displacements. A displacement versus time graph is going to look like this. Where you're going to have some position over time, and you're going to have a graph that's going to look something like that. So the first thing that we have is, what does the y-intercept mean? Well, the y-intercept means is where at time equals 0 your position is at time equals 0. So this is your starting position. So this is your initial position of where you are at equals time equals 0. So this is where when the gun goes off in the track and all of a sudden you're racing down the track, this is if you were given a head start, rather than if you had another graph that would just look like this, where you would start at 0, 0. And you could be located even below the x-axis, and that would mean that you're giving the person down here, you'd be located behind the start line. So that's what your x-axis, the y-intercept in a position versus time graph. Now we got to look at the slopes. What do the slopes look like? Well, this slope right here compared to this slope compared to this slope, what do they mean? Well, I am moving a certain amount of position in a certain amount of time. And so if we look at the slope equation, it is rise over run. Well, our rise is our position, and our run is time. That should look familiar. Your delta x over t is your velocity. So the slope represents your velocity. So in this case, our slope here is a positive velocity of some number. We don't know what it is. I haven't put any numbers into this graph, but it would be, if we could find the slope of this line, it would be a positive number. What about this slope when you have a flat slope? Well, the slope would then be 0, so its velocity would be 0. So let's look at that here. If we are here at position, let's say 25, and after a certain amount of time, let's say 10 minutes, and then after 15 minutes, so 5 minutes happened, you are still at 25. You have not moved. You are staying at 25 meters away from the origin spot, and you are not moving until time equals 15. Now let's look at this negative slope. This negative slope is going to represent a negative velocity. So that's going to represent a going backwards towards the origin. But what happens when it passes the origin right here? Well, this is just meaning that it's going away from the origin, backwards, away from the position. So this is going up, you're moving away, stopping, not moving, Now you're going backwards, back to the start line. You actually get to the start line again, and this time you are going backwards. So when it's below the x-axis, that means you're actually going away from the start line, but in the negative direction. So let's go back and fill this chart out. So we said that the y-intercept is the initial displacement. The slope is going to be the velocity. So if it's a positive slope, it means it's a positive velocity. If it's a negative slope, it's a negative velocity, or you're moving in the negative direction. If you have a zero slope, it means you are stationary, at rest, not moving, however you want to say it. Now, if you are if the line is straight, that means you have a constant velocity, and if it's curved, it means you have a changing velocity. And let me show you what that means. If you have a velocity that looks like this, that means your slope, aka velocity, is the same throughout this whole thing. You're not changing it. But if you have a curved line that looks like this, the slope here is pretty darn close to a very low number, if not even close to zero. But as we come up, this slope is constantly getting higher and higher and higher, meaning the velocity is getting higher and higher and higher. This has a changing velocity, while the red has a velocity that is constant. That's just some number in meters per second, or you could say miles per hour. But this one, in the green, you're changing that velocity. This also means that you're accelerating. So if you are going up and it's curved, it can mean that you're accelerating. Now, it can curve in other directions. You can curve up, you can curve down, and you can actually curve the other ways. And these just all mean acceleration, that you're accelerating or you're changing your velocity. So again, we look at this, and you can add in right here acceleration if you so desire. So a curved line on a displacement versus time graph is acceleration. Now, area under the curve, this is going to be different. This is going to be your, what we call in calculus, integral. But we're not going to deal with that because this doesn't exist on the displacement versus time graphs. So in displacement versus time graphs, it does not exist, so we don't have to worry about it. Now, curves coincide with objects having the same displacement. So let's look what that means. If I have two graphs and they have the exact same slopes, well, they have moved the exact same distance over time as each other. The triangles are same. They're offsetted from each other, but they are exactly the same. So the distance of, let's say, this triangle is going to be the exact same distance it's traveled as this one. So the slopes, when they're same, their positions are the same. Now, how do you know if the object is stopped? Well, we already talked about that, but it's when you have a horizontal slope. So when the slope is flat. It's moving if it's positive, it's going negative, or it could be even curving but we all know that it's stopped when it has 0. And then how do you know if it's accelerating? Well, it has to have a curve, and we give that in mathematics, we call that a parabola. So when we have a parabola, we know the object is accelerating. So we know that the object is accelerating when there is some curve to our line. In calculus, you'll learn to actually calculate the slopes of this, and that's what calculus does. In this class, all we need to know is curves equals acceleration. That's it. So that's our first part of this video. The next video will be our velocity versus time graphs, and we will then go into velocity versus time graphs and our acceleration versus time graphs. If you have any further questions, go ahead and ask your teacher. Thank you.